Welcome to Chronicles of the Curious, where we explore the fascinating and mysterious aspects of science and nature. In this video, we will talk about a quantum computing breakthrough that has been achieved by scientists from Google and China, who have demonstrated quantum supremacy over classical computers. Quantum supremacy is a milestone that means that a quantum computer can perform a task that would be impossible for a classical computer, even with unlimited time and resources. Let's dive into this amazing topic and see what this breakthrough means for the future of computing. Quantum computing is a new paradigm of computing that uses the principles of quantum mechanics, the branch of physics that describes the behavior of matter and energy at the smallest scales. Quantum mechanics reveals that nature is fundamentally probabilistic, uncertain, and entangled, meaning that particles can exist in superpositions of two or more states, can have indefinite properties until measured, and can influence each other instantaneously over any distance. Quantum computing exploits these features to encode and process information in a radically different way than classical computing. Classical computing uses bits, which are binary units of information that can be either 0 or 1. Quantum computing uses qubits, which are quantum units of information that can be 0, 1, or both at the same time. This means that qubits can store and manipulate more information than bits and can perform parallel computations on multiple states simultaneously. Quantum computing also uses quantum gates, which are operations that manipulate one or more qubits by changing their states or entangling them with other qubits. Quantum gates are analogous to logic gates in classical computing, but they are reversible and unitary, meaning that they preserve the total information and probability of the system. Quantum gates can be combined to form quantum circuits, which are sequences of quantum gates that perform a specific task or algorithm. Quantum computing has the potential to solve certain types of problems that are intractable for classical computers, such as factoring large numbers, searching large databases, simulating complex systems, optimizing hard problems, and breaking encryption schemes. However, quantum computing also faces many challenges and limitations, such as decoherence, noise, error correction, scalability, and programmability. Quantum supremacy is a term coined by physicist John Preskill in 2012 to describe the point at which a quantum computer can perform a task that would be impossible for a classical computer to do within a reasonable amount of time or resources. Quantum supremacy is not an absolute or universal concept, but rather a relative and specific one. It depends on the task, the quantum computer, and the classical computer being compared. Quantum supremacy does not mean that quantum computers are superior or faster than classical computers in general, or that they can solve any problem that classical computers cannot. It only means that quantum computers have an advantage over classical computers for some problems that exploit their quantum features. Quantum supremacy also does not mean that quantum computers are useful or practical for real-world applications. It only means that quantum computers have reached a proof-of-principle stage that demonstrates their potential power and feasibility. Quantum supremacy is an important milestone for quantum computing research and development, because it shows that quantum computers can achieve something that classical computers cannot, and that quantum mechanics can be harnessed for computation at a large scale. Quantum supremacy also opens new possibilities and challenges for exploring the limits and applications of quantum computing, and for advancing our understanding of physics and information. Google and China are two of the leading players in the field of quantum computing, and they have both claimed to have achieved quantum supremacy over classical computers in different ways and for different tasks. Google's claim was published in 2019 in the journal Nature, and it was based on an experiment performed by their quantum processor called Sycamore. Sycamore is a superconducting chip that consists of 54 qubits arranged in a two-dimensional grid, and that can implement various quantum gates and circuits. Google used Sycamore to perform a specific task that involved sampling the outputs of a random quantum circuit, which is a sequence of random quantum gates applied to the qubits. Google argued that this task is hard for classical computers, because they would have to simulate the quantum behavior of the qubits and the gates, which would require an exponential amount of memory and time. Google estimated that the most powerful classical supercomputer in the world, called Summit, would take about 10,000 years to perform the same task that Sycamore did in about 200 seconds. Google also showed that Sycamore's results were accurate and reliable, with a low error rate and a high fidelity. China's claim was published in 2020 in the journal Science, and it was based on an experiment performed by their quantum device called Jiuzhang. Jiuzhang is an optical system that consists of hundreds of beam splitters, mirrors, prisms, and detectors, and that can implement various quantum operations and measurements. China used Jiuzhang to perform a different task that involved sampling the outputs of a boson sampling problem, which is a problem that involves counting the number of photons or particles of light in different modes or paths. China argued that this task is also hard for classical computers, because they would have to calculate the probability distribution of the photons, which would require an exponential amount of computation and time. China estimated that Summit would take about 2.5 billion years to perform the same task that Jiuzhang did in about 200 seconds. China also showed that Jiuzhang's results were accurate and reliable, with a low error rate and a high confidence. Both Google's and China's claims have been met with praise and skepticism by the scientific community, as they have been challenged by various technical and theoretical issues. Some of these issues are: the choice of the task. Some critics have argued that the tasks chosen by Google and China are artificial and contrived, and that they do not reflect the real capabilities or applications of quantum computers. They have also suggested that there may be alternative or better ways to perform these tasks on classical computers, using different algorithms or methods. The comparison with classical computers. Some critics has argued that the comparisons made by Google and China with classical computers are unfair or inaccurate, and that they do not account for all the factors or resources involved. They have also questioned the validity or reliability of the estimates or assumptions made by Google and China about the performance or limitations of classical computers. The verification of the results. Some critics have argued that the verification of the results obtained by Google and China is difficult or impossible, because it requires either using another quantum computer or simulating the quantum system on a classical computer. They have also pointed out that the error rates and fidelities reported by Google and China are not sufficient or conclusive to ensure the correctness or quality of the results. Therefore, Google's and China's claims are not universally accepted or settled, and they require further scrutiny and confirmation by independent experiments and analyses. What are the implications and challenges of quantum supremacy? The implications of quantum supremacy are significant and far-reaching for both science and technology. Some of them are: it marks a historic achievement and a proof of concept for quantum computing, showing that quantum computers can outperform classical computers for some tasks, and that quantum mechanics can be harnessed for computation at a large scale. It opens up new possibilities and opportunities for exploring the limits and applications of quantum computing, such as solving hard problems, simulating complex systems, optimizing hard problems, breaking encryption schemes, and advancing our understanding of physics and information. It creates new challenges and questions for developing and improving quantum computing, such as reducing decoherence and noise, increasing scalability and programmability, enhancing error correction and verification, and finding new algorithms and methods. It sparks new competition and collaboration among different players and stakeholders in the field of quantum computing, such as governments, companies, universities, and research institutes, who are all striving to achieve quantum supremacy or quantum advantage for different tasks and goals. We hope you enjoyed this video and learned something new about this quantum computing breakthrough that has been achieved by Google and China. If you liked this video, please give it a thumbs up and subscribe to our channel for more videos on science and nature. Also, let us know in the comments what other topics you would like us to cover in the future. Thank you for watching and stay curious.